Okay, today we're going to be working on a Rave at the Grave. Rave at the Graves, technically, since it's got an apostrophe S. This was sent in by somebody on one of the Lemax forums, Ashkari Mohammed, and it's not working right. I have an idea what's wrong with it, but we're going to take it apart. Here's what it looks like. So the lights work, volume works, no movement.
Welcome to the Rave at Grave. Like me to take your grill?
Thank you, fella. I'm going to say it's either got a bad motor or bad micro switches. The only reason I would say that is I just helped someone else fix theirs via the internet, and they needed micro switches, and that's why theirs didn't function. So, I can only assume it might be a defect with this specific model, not this one in my hand, or it's just coincidental that this one's also not functioning correctly either. So, like all of them, first thing we do is take the bottom off. There are some wires that are stuck right underneath. So if you do this, be careful. Probably should have done this in advance, but it is what it is. And those are the wires I'm referring to. So if you're using an X-Acto knife, be careful. You don't want to slice the wires. That's one thing I like about the spudger. It's not as sharp. So it doesn't always do the job, but it does allow a little layer of protection against tearing up wires. They do make spudgers in plastic, but I like the metal ones because they flex and give you some spring. Plastic ones have a tendency of just snapping. Well, the glue is broke. I don't know if I'm not quite able to salvage the bottom. But we'll see what we can do. Might be workable. Now the bottom is hot glued in, so see if we can break some of this hot glue free. Probably need a little bit of a sharp edge right here. And that's the center. So here's the little figures. We have a micro switch right down here, another one right down here. They seem to be intact. We got the motor and the drive mechanism in the back. I'm going to lift it up and try and show you the inside where the circuit board is, as well as your power and your bunch of wire for all the different lights. So let's see if we get the grip. You can see in there, you can see the circuit board mounted on the back right there. Here's hopefully a little closer view of the motor assembly. And if you look right there, you might see the micro switches. They're the black and white, or silver and white items. Oh, and the speaker, if you didn't see it, is tucked up and glued in the corner. So, see if the motor spins. No, that motor is not spinning. It's trying. I'll take the belt off of it to release the stress and see if it spins freely. I don't know if you can hear it. I think the motor's bad. You hear that grinding sound? It's usually a bad motor. So it's not rubbing anything. I'd say it's rubbing against the plastic housing, the spinning shaft or the pulley. It's not rubbing anything. We're going to take this whole section apart though, right here at least, as much as we can, and check the gears because, you know, it's pretty typical that you always lose a gear, and it's usually the little 10 tooth. So, take these screws out and start disassembling the back. So there's two screws behind the decorative spacer, and there's two screws in front. And this is where these little narrow electronic screwdrivers come in handy because I can fit it between the backer picture and the characters. And let's see if I can get the screws completely out. There's one. And two. I'm going to set the screws over here with the belt. It looks like this backer is going to have to come out too. I think it's got a little dab of glue in here. I don't see any screws or any other fixment points. Take out the entire motion deck and see if there's something I'm missing. Yeah, this pulley doesn't want to turn and make these people move very well. I'm thinking I might have a broken gear that might have fried the motor. Yeah, I can feel it. If I force my way over the stopper point, you can feel the gear. So I think it's got a bad motor and a bad gear. But I got to move them all to get to this other screw. There we go. You can probably see the little teeth right there. That's the front one. And then the teeth are on both sides for the back row. Here's your lights to make these guys glow. Move this out of the way. And hopefully you can see in the camera, these are your micro switches. So we have a little idler gear here. Yeah. We're not getting any drive on this bigger gear here, which transfers to the back row, which then of course hits this, which makes the front row move. So there's definitely something wrong with the gears as well as the motor. Now I just need to get this piece off, which appears to be glued. So I'm going to use the spudger and see if I can pry back the two plastic tabs on this side, and then try and pry the one on this side here down at the bottom. Yeah, it looks like there's a dab of hard glue, probably a super glue style. Got some movement. See if I can wedge it up so I can get this side to move now. So now I need to try and get the next tab over to pop. And I'm going to try an X-Acto knife for this. Not drop everything in the process. It's a straight blade, kind of like a scraper versus an angle blade. Because it has a sharper edge, I might be able to get through the glue easier than using the spudger. Now let's see if the whole side, yeah. So if you have to take this thing apart to this extent, you probably want to get a sharp scraper or pusher style. Yeah, even a razor blade would work if you can get in here with your hands and go in the back, at least on this one, and cut the glue. You can see the rough glue. Oh, you can put it back together with super glue, like they had it, or you can put it back together with hot glue, which makes it easier to take it back apart if you think you're ever going to have to take it apart. So, we got debris in the gears. That might be causing some of the problem. It's not hard debris, it's just a foam, feels like. Probably packing from the white foam. But in these fine teeth, the foam can stop it from turning. So now I'm just checking the gears to see if they're broken. It may not have a broken gear. It may just be the foam, which is everywhere in here, got stuck in the teeth and was wedging it. And what I felt the clicking was is the foam going through the teeth, kind of like a grinder. So make sure it didn't damage any teeth. Alright, I think I got all the teeth cleaned now. Yeah, I still don't like the way that motor sounds. It's not as loud as it was, but it's a standard 3-volt hobby motor. Excuse me, 3 to 9 volt hobby motor. We'll probably end up replacing it here in a few. First, I want to see if that is the only issue, if it was the motor going and the stuff in the teeth. It's spinning. Now let's put the gearbox assembly back into its place. And let's see if these gears rotate, which they are. So, yeah, there's just this white foam everywhere. There's some inside the house too. Now, timing is somewhat important on these because this hits those micro switches. So you need to make sure that 1, you have it timed, and 2, they're staggered from each other. So the characters cross each other, which you're supposed to. But I realize there's foam on both the micro switches. So let's get the foam out. And there's fuzz. Kind of looks like the puffy foam rubber stuff we use for packing on bigger things. So set that in there. Yep, fits. Let's get the back row in. We'll start it staggered off to the left. Get all the teeth to line up, get it to fit in its track. There you go. Get the front. There we go. And get this guy staggered off to the right. This probably going to take a little practice if you have to take it apart to this extent, because you got to get everything to fit into its groove. And that's where I'm having the issue at the moment. There we go. But once you get it to line up, it lines up. And because this is under tension, I'm just going to put 2 screws in diagonally so none of this pops apart, because it's going to be moving. And I don't want it to pop apart and 1, give me a false indication of what's wrong with it, and 2, You don't want it to damage the teeth on those gears. So it looks like the gears are fine. It looks like the reason the gears are having a problem is there's just debris in them. But to ensure that they don't hit the other screws, I'm going to pull out the other screws that are going under, I guess we can call them the bleachers, so that the bottoms don't smack it and wedge it. So it is moving. Not very fast. It's this motor. Yeah, the motor's dying. So oh, let's get a new motor popped in this thing. Now this motor is a 300 CA. It's the part number you'd look up. It's a very standard motor. I believe the 300 CA is rated 3 to 6 volts. And I have one sitting on my bench here. Probably put it away. Now let's take a look. Let's look at my motor bucket. This motor I'm trying to read it. This one's not printed on, it's etched in it. I think it says 5719. But we'll test it, make sure it's going to work at the voltages required. And this one says 400 CA. And this one's 300. And you can see these are about the same thickness. Here's a 400. You can see it's about 3/4 as tall. It'll probably still work, but being shorter, it's going to have more load on it. So we don't want to use one of those. And I got so much stuff on my bench. So let's test this little motor, make sure it can handle everything. Right now it's spinning. You can't see it, unfortunately. It's at 4.6 volts. Spinning right along. So what I'm going to do is the wires are hot glued down. I'm not cutting the wires. I was using the snips to lift the edge of the glue before I do anything. So here's the wires. They're red and black. I'm going to cut them off in just a moment when I get this glue out of here. That. Bye. I'm not cutting this. I'm using this as a pry to lift the pulley off. Shoot the pulley off. Let's see if I can find it. Hold, please, while I go find that pulley. All right. Huh. Ain't nothing like a thing to go flying for you to clean off your workbench. But I found it. It shot across the bench and landed in this random plastic bag. So, yay, go me. It fits perfectly. There's the old one, which has 3 screw holes. This one has 6. Hopefully the original screws are the same thread. We're going to find out here in just a moment. They are. That's good. These screws have much larger heads and longer shanks that go through the plastic, while the screws that came with that motor are very small. This little motor came out of a Walkman. Alright, now we're going to reassemble it and test it again. I'm not going to test it using the house power. I'm just going to give it direct power just to make sure that everything works like it's supposed to. So, redo the process again by reinstalling. Off to the right. Set that on loosely. This one's off to the left. So, 2 screws. Now the 300 CA motor is a very standard motor for most hobbies. So if you needed to find one, you can find them on Amazon and eBay pretty much all day long. The cheaper ones come from China, of course. They take longer to get here, and generally you have to buy them in packs of like 3 or 5. You know. Some places might sell 1, but it's pretty rare. If you have any old electronics lying around, like I said, this one came out of an old Walkman. Recycle most electronics if I can, and little hobby motors are always handy, especially when you have this hobby of animated houses. Okay, I have my timing out of whack. This one's already at the end of its cycle, and this one's not. So, I'm going to back it up so I can unscrew it real quick and adjust the location of the teeth. I think I'm off about 2 teeth. That. That's the other reason I wanted to test it outside of the house, is so if I put any strain on the motor, it doesn't try and backfeed the board. You can always mark these before you do it so you don't do the timing. Probably also helps if I put the belt back on. Alright, why is it not reading the micro switches? You can reverse the polarities on these motors, so you can make them drive forward or backwards. Oh, dumbass. It's not reading the polarity because I have it disconnected from the house. My bad. But it is working and it's much quieter. So now let's hook it up to the house and see if my timing's right and the micro switches do their job. The micro switch does is it actually just reverses the polarity. But it does it at the circuit board level, not at the motor. I'm just twisting the wires together to test it. Once it's correct, we'll solder them and protect them with either heat shrink or liquid electrical tape. And then re-hot glue the bundle of wires back to the base so they don't get caught in the rotating mechanism called the gearbox. Why are you stuck? Let's turn the volume down. Okay, well apparently there's an issue. The motor spins. She's still having a hard time turning this. I'm just troubleshooting it, trying to see why it's having a hard time turning the gearbox using the power coming from the house. It spins freely with my thumb. Alright, well it is moving, but it's still got some issues, so there's something else wrong inside this gearbox assembly. That or the power coming from the house is not correct. Let's see what the voltage is coming out of the house. .6 volts. The power supply I have, I can reverse it from sending power to reading power. So right now it's telling me that these two wires which drive the motor is 4.6 volts. Wow, it's got a huge voltage drop. Alright, when it was moving, that just by itself a moment ago, it was dropping from 4.6 down to 3.2, and when it was stuck and the motor was just squealing, it was pulling, it went down to 0.5 volts. So it's possible the motor's weak as far as the load, because it's not a 300 CA. So I'm going to unscrew it and see about putting in a 300 CA if I have one. This time I don't plan on shooting the pulley across to the bench. Hold it. So let's go back to my motors and see what I have. So I'll return once I find the 300 CA motor and see if it's a load rating. The difference between a 300 CA and this D, I don't know, 5103 or something like that. I can't read it again because it's laser engraved. But see what I can find. See if we can get this thing fixed. Be back soon. Okay, I found a 300 CA motor. I put it in. So here's the original one, which I think is bad, may not be. Here's that D whatever number one. But in testing it, I think the problem doesn't lie with the motor. I think the problem lies with the circuit board. And I'll show you what I mean. These are just holding the wires together. They're not providing power or anything. I'm just using the clamping action to hold the wires. So if you notice, if I can hold this, nothing's turning. If I hit this micro switch, you can hopefully hear and see it. You know what I'm going to do? Just to make life a little bit more visual, we'll add a little Sharpie line. So that micro switch spins. When it hits here, it's supposed to go back and then touch this micro switch. Notice to stop spinning. There's no load on it other than just a pulley. When I do this, turn the volume down, and I click here, there's a squealing sound coming from inside the house. I thought it was that other motor. I think one of the components on the board is failing, probably a transistor, since it has about a dozen of them sitting on it. I'm going to have to take the board out, trace the motor wires, see where they connect to, and start tracing backwards. Because whatever is causing it to switch polarity, that's connected to this micro switch, is failing. Because it should start spinning the other direction. That's the whole point of these switches. So, but as you can hear, this motor is a lot quieter than this motor. So this motor still might be bad, and it might be bad caused by the circuitry of the house starting to fry the motor. Or the motor started going bad and backfed the house and fried the circuitry. Either way is possible, but this motor, when I free roll it on the power supply, sounds crunchy. But it spins fine and it's drawing the correct amperage, which is 2 milliamps with no load. So reverse, stops turning, nothing. Even if I try and make it go, nothing. But and it goes from 4.6 volts to 0.2 volts. Sometimes I get 1 volt. So something in the circuitry is failing. And if it's a discrete component, should be able to replace it. If it's a chip, it's going to get a little harder, especially if it's the Blob Chip. If the brain is not telling the thing what to do correctly, then unfortunately it's not going to be repairable. So we need to get the circuit board out. And this is like one of the other houses. I can't remember which one. I think it was a Christmas house. Circuit board is held in from the outside behind this piece of fake wood. This fake wood is actually a screw cover. It is glued on, so it does require you to break it off. If you do it carefully, you can re-glue it back on. And there's the screw. The problem is it's full of glue, so I can't get a screwdriver bit in there. So I have to work on getting all the glue out of the screw head. At least it looks like it's hot glue this time. Last time I did one, I think it was super glue, which is really hard to get off of things. Hot glue stretches and then peels off. Yay. And there's the screw. Little machine screw. And here's the circuit board with its gazillion wires attached to it. So, like I always suggest, take a picture. Or 2. Or 7. Try and take a picture where everything goes, in case you break a wire. Especially these in the back. So, unplug the speaker. And these two plugs, which are the same, these Molex style connectors, this one says SP for speaker, and this one says C8, which I have no idea what that goes to. C8's the motor. Here's the motor wires. So, I'm unplugging those so I can get a better picture of this bundle of spaghetti. Really trying to get inside. I have a funny feeling some of these wires might break off. It's not my plan, but you never know. Oh, sorry, it's M1 motor. the C8's the capacitor next to it. So I read it wrong. So M1 and SP, motor 1 and capacitor C8. So now have to trace the tracks. So we know the motor is not reversing polarity, but we also know this micro switch, the 2 red wire micro switch, is the part that's not working. So we're going to trace the 2 red wires up, and this is where things get interesting. This red wire is attached to that resistor, and this red wire, we think the polarity flipper is this little green circuit board. Okay, this one's 2 black wires. Where do they go? 2 black wires, one shares the same red and the other one goes to this resistor here. So R8 and R9. R8 is this, R9 is the red through these 2 resistors right here. And the 2 common power wires are right under this circuit board. And that track goes to that transistor in one direction, and in the other direction it's attached to a white wire, sorry, yellow wire that goes up to the power. So how is that switching polarity? There's just glue strings across the top. This chip should be the amplifier for the speaker. Yeah. Alright, time for some magnification squints. I can read the transistors and see what they are. So resistor, jumper, resistor, jumper. Alright, let's trace the other sides where these 2 resistors go. Okay, that one goes here. Get these wires out of all my way. So This track goes to there. Yeah, this board here, this little green guy, I think is my voltage reverser or flipper, switcher, whatever you want to refer to it as, which has 4 resistors on it. 1, 2, 3, 4. And how does it switch the polarity? Where the rest of the wires go? It could be a light board, actually. Never mind, that's the light board. They just share common. That's why it goes back to that board. Alright, back to tracing. Coming back to the resistor bank, which goes right back to the IC or Blob Chip. This might actually just have a bad Blob Chip. That would be really bad. These 2 resistors are connected to the polarity. Let's trace the motor back, see where the motor goes. So here's the motor. That's connected to this transistor. And it shares capacitor and a resistor. 2 resistors. And the other pin goes to 2 resistors. 2 and that. And a different transistor. I'm wondering if I lost a transistor. The transistors on this are SB050, which is different than most of them. Most of them are C1815s. That's what these are. These are for the flashing lights. These 4 right here are your light sequence transistors. And that's a C1815. So these 4 are SB550. One of these might be bad, or maybe the capacitor is bad. I doubt it. It doesn't look bad, and I'm still getting power in one direction. Capacitor is probably just a smoothing capacitor for the noise of the motor. So it doesn't backfeed the board or cause the speaker to pick up interference. All the components technically look good. I don't see any discoloration, burns, smoke, and issues as far as something like the smoke out. The 2 big capacitors aren't bulged. This is going to take some further investigation and see if it's repairable. If it's a transistor, I have the 1815s. I don't have any of the 550s, the SB550s. So if one of these 4 is the culprit, I'd have to order them. If it's one of these 5, which I doubt it, because again, they usually use in most Lemax houses, these are used for the light sequencing. I have these. These 4, which are the orange, yellow, black, and green, and red wires. There's 5. They all go up to the lights. This one up here is yellow. These over here on the points are black. Yeah, so these are going to be your light sequencing wires, or transistors. This is what makes it flash in its different patterns as it gets signal. The houses that don't have animatronics, that just have lights and no sound, will have a bank of these to do the lights back and forth. So, anyway, instead of boring you with me sitting here with a meter and going through every component for the next hour or so, I'm going to see if I can diagnose it down to what has failed and go from there. But at the moment, I'm thinking it's one of these 4 transistors. So, we shall return once we diagnose it. Thank you. Okay, it's been a couple of weeks. We've tried a few different things to try and make this work the way it's supposed to. Drew up some designs for some mechanical switches. Anything we could do electrically to make the characters move, and unfortunately, everything we do doesn't last. So, this one is not, at the moment, repairable. But it does light up, and it does still talk and play all the music. The characters, I offset them when I put it back together so you can see the 2 rows when you're looking at it from the front. It has a new bottom on it. That's why I scraped off the old Lemax one that tore and placed a whole new rubber mat, or foam rubber mat, sorry. But unfortunately, I cannot get this to work where it's going to be reliable. It does have the new motor inside. Not doing anything, but it is sitting there. The wire for the motor is unplugged from the board, and it's coiled up, and then it's twist tied to the cabling that was glued to the base that you saw me break off earlier, right in here. The reason it's done is if you ever find a parts house, one of these that's broken, maybe at a Goodwill or garage sale, and they're selling it for a couple dollars, but the board works, we can swap the board. Or later on down the road, if a design comes out to where we can make a mechanical or a new electrical switch that works with the existing power that is reliable, make it so it goes back and forth again. Basically, the problem is we're not getting the polarity reversal signal from the chip when the chip is told to change polarity by the microswitches. Microswitches work, but the chip is hell-bent on sending it in one direction, which burnt the old motor up, which is right here. And the problem is if I put the motor back in and wired it, it would just do the same thing to the new motor. And eventually, which is possible, when a motor fails and you keep sending power to it, I see this on bigger motors that I work on my daily job, it can backfeed the circuit board. And then the circuit board burns out. Well, then it would be a useless prop. It wouldn't light up or anything. So at least for now, it lights up, makes noise, you just don't have the motion. So it will be going back to its owner, and with the information, of course, what I found. So this is one that at the moment cannot be repaired. It's pretty rare, but unfortunately it does happen when it comes down to the chip that fails. So at least at the moment with this video, you saw how to get into it, hopefully how to diagnose it a little bit with a multimeter. Some where the gears are, the standard gears that are in here, where they break. You can buy a gear pack and a belt pack from Amazon. I've showed it before, but here's the gear pack and belt pack that's pretty standard from Amazon. There's the name and there's the part number, which when you get it, looks like that. It has some basic belts, but it does have some of the standard gears used in most animatronic houses. The rest of the gears really don't work in the houses, but for 10 bucks, it's better than nothing. This house uses the gear tracks like this, which are pretty, well, for most animatronic houses, useless. But the gear tracks in this are cast into the base. But if you got creative and you broke the teeth off on this house as an example, you could technically, Dremel off the broken track, cut this to the length, and then adhere it either with, I would use super glue, not hot glue, or itty bitty little screws through the holes. So even though that kit comes with these bars, you might have a use for them at some point. Other than that, they're pretty useless for what we do with animatronic houses. So there you go. It's unfortunate it's not fully functional, but it's still a good light up prop that makes sound for any display. So thanks for watching. Until the next one, have a good one.